Grand Canyon is a spectacularly beautiful place. It's as if God split the earth open and said, look at this. And yet, when we look at it, there are lots of questions that we start asking. Where did all of these layers of rock come from? And what happened to all of the material that once was inside what is the canyon now? Those questions can really trip up a person's faith. One individual who decided to investigate the Grand Canyon and other areas on the earth is Ariel Roth, and we're going to look at his story now.
When you come to the edge of the Grand Canyon, you look over that huge chasm there, and you see that teeny little river down in the bottom, little changes going on. Probably the river carries a little bit of sediment, but it looks old. One can get the picture, that there is, it took a long time. But that's if you want to limit your thinking to, hey, everything has to be just the way it is now. The Bible spends 2 chapters telling us about creation. It spends 3 chapters telling about a flood, a major flood. And that major flood changes the whole landscape of geological interpretation. How could a little river like you have there cut that canyon? We have lots of peaks and buttes in here that don't fit what you'd expect from a river, more what you'd expect from a major flood, as the Navajos and the Hualpai Indians and the Havasupai Indians believe, and as the Bible tells us. I was born in Switzerland, grew up there for a few years, went to France for 1 year, and then went to Haiti, where I spent most of my young childhood, mid-years of youth there. Through all that, I always was interested in science. I can remember one time my dad was giving a evangelistic series about the Bible, and he mentioned in there about fossil man, and he had various pictures of fossil man up there, discussed how there were certain problems, evolution with those, and that kind of intrigued me and started my interest in this issue. Things became much more interesting when I went to college and took a course from one of the professors there who was a creationist in the philosophy of science. And then I realized that there's a real issue here between science and the Bible. I went to my college years at Pacific Union College, and there was a professor by the name of H.W. Clark, who is one of the icons of creation. And I took some classes from him, and he certainly stimulated my interest in this issue. Things really came to grips when I went to the University of Michigan, started taking courses, their graduate courses. I felt that, these teachers are good teachers. They're great teachers. The classes were excellent, but they kept on telling us about how evolution was true. And I thought, man, there must be an agenda here. Unknown to me, when I went to the University of Michigan, 2 persons who believed in the creation of the Bible had come to the same department I was in at the university, and they had been excused from the department because of their beliefs. I thank God that I got through there. So they had the professor of evolution interview me. He called me and asked me, what are your views anyway? And so I told him, I can follow your reasoning to a certain extent, but then I run into certain problems. What problems are they? I thought, when you go down in the fossil record, you look at turtles, and they're turtles, and the turtles have the anatomy of the turtle all the way down, with the pectoral girdle inside the ribs and so on, a very unique type of structure. problem is that you go below that, you don't see any intermediates to that, you know. And he said, well, yeah, there are problems. Keep in mind, there's one suggested intermediate there, but it doesn't qualify. And then he asked, do you have other problems? I said, well, I don't know why a warm-blooded animal should ever evolve from a cold-blooded animal, because a cold-blooded animal is so much more adapted to its environment than a warm-blooded animal. And after a few minutes, he told me, you're okay. If there is a designer, you'd expect that he would communicate with us. That we just happened by chance, that this I cannot accept, and I think most people feel that there's got to be something behind all this. If there's a long, long time here, in contrast to the biblical model of just a few thousand years, there ought to be those factors, those questions, those tests that could tell you, hey, was this deposited rapidly? Was this cut rapidly and so on? Or was this the result of the millions of years that are usually attributed to the Grand Canyon? I discovered that between some of the layers of the Grand Canyon, parts of the geologic column are missing. And in some cases, it's rather major. Toward the bottom of the Grand Canyon, there's no Ordovician or Silurian. These two major periods are missing. There's 100 million years there. And you look at the Grand Canyon, you see how irregular the erosion is. And you look at the contact between them, you see how flat they are. You wonder about why is that so flat if there's all these millions of years? What you see here is some gaps where parts of the geologic column are missing. And we'd expect a lot of erosion there. Right below the whitish layer that you see across the way there, not the very top one, but the most distinct whitish layer, tan layer there that near the top is the Coconino sandstone. Below that Coconino sandstone, we have a gap of about 6 million years. And you'd expect maybe 600 feet of erosion as a minimum. Some would say much more. Inside the reddish layers, you have another gap of about 14 million years. And you'd expect at least 1,400 feet of erosion there as a minimum. And then you go down, you see a sharp cliff, vertical cliff. That's the red wall. And just below that, there's a layer called the Temple Butte Formation. Below that Temple Butte, you have a gap of at least 100 million years. You know your geolite column, but there is no Silurian or Ordovician there. And over 100 million years, you'd expect on an average at least 2 miles of erosion. Yet the layers lie there very flat, one on top of the other, suggesting that that time never occurred.
Down here a little lower in the Grand Canyon, you can really see these flat layers. If you look over here, you can see the massive Coconino sandstone. That's that big cliff right there. And at the bottom of it, you see the red Hermit Shale. The Hermit Shale is supposed to have sat there for several million years before the Coconino sandstone came on top of it. And yet, we don't see evidence of millions of years of erosion there at the interface between these two layers. What we see is a flat line. Maybe that indicates that the millions of years actually weren't there. They never existed. Those two layers came together relatively rapidly.
I found out, well, there's some other places where there are gaps here. There's a 14 million year gap in the middle of the red layers there in the Grand Canyon. There's a 6 million year gap at the bottom of the lighter Coconino near the top, and so on. And yet those layers are there very flat, and it seems to me that those millions of years never occurred. Geologists, when you don't have deposition, you have erosion. So there's probably no place on the Earth where you don't have either deposition or erosion in terms of, millions of years of activity. You'd have this. Erosion tends to be very irregular. And you look at the Grand Canyon, you see how irregular it is as an example of erosion. And yet, these contacts are very flat. Charles Darwin, in his famous book, The Origin of Species, tries to defend the fact that there isn't irregularity at these flat contacts where there are gaps. And he says this can be explained by the fact that these layers were in the bottom of the ocean.
The many cases on record of a formation conformably covered after an enormous interval of time by another and later formation, without the underlying bed having suffered in the interval any wear and tear, seem explicable only on the view of the bottom of the sea, not rarely lying for ages in an unaltered condition.
Well, the argument doesn't hold at all for several things. One, the layers in the Grand Canyon are not bottom of the ocean layers. But secondly, at the bottom of the ocean, you have sediment deposition. So you don't have a gap. These things are extremely widespread. We're talking about some of them hundreds of thousands of square miles. And when you have kind of a flat pattern for 100,000 square miles, no erosion, and it's supposed to have nothing, no activity, that is no depositional activity for so long, it doesn't fit the long ages model. It looks like things were laid in rapidly, as you'd expect during the Genesis flood. In 100 million years, you would expect about 2 miles of erosion. The Grand Canyon is only about a mile deep. Did that 100 million years ever take place? Well, some evolutionists would say, well, yeah, they just piled up and it eroded back down to that. But that doesn't work at all because erosion is not that flat. Those layers, look under there. The contacts are generally flat. There's a little bit of erosion at them. Once in a while you find a little bit. You'd expect that during the flood. No problem as far as the flood model for that. It's rather striking evidence that those things were laid down much faster than the geologic time would suggest, and would suggest the biblical model. Well, that fits very nicely with that particular concept. Now, one of the very puzzling things about the Grand Canyon, that river cuts through a dome. This is not where rivers normally go. The river could have gone south of the Grand Canyon at a lower level. It could have gone north of the Grand Canyon at an even lower level. No, the river cut right through the dome. And this is part of the big puzzle of the Grand Canyon. It seems to me so much easier to cut that Grand Canyon as the receding waters of the Genesis flood. Here we have the flood covering the earth. We have lots of layers laid down by that flood. At the end of the flood, the waters recede and it cuts the Grand Canyon. One of the interesting features of that's explained by this is the fact that you look at the Grand Canyon, it's about 1,000 cubic miles of material that's been cut out. That's nothing compared to the real erosion problem you have around there. From the layers above the Grand Canyon, you've got 15 to 30 times as many. We're talking about 15,000, 30,000 cubic miles of material above that has to be washed out also. That's seldom considered in the model. It's called the Great Denudation. Geologists recognize this. They think it took a long time. How are you going to wash all that out? It's so much easier to wash it out with the receding waters of the flood. And when you look at the side canyons of the Grand Canyon, there are hundreds of these. They cut to the edges of the Grand Canyon, but there are no streams in many of these, most of them, there are no streams to cut down these side canyons. Some of them are major canyons. But if it's the receding water of the flood, they would cut this out and get after that. Hey, you look at that canyon, it's pretty clean. All those side canyons, they're pretty clean. What washed all that out? Why didn't the debris just fill in these side canyons and so on? That seems to fit better with the idea of the flood.
Most of the Earth is actually covered by water. So for a man who wanted to study the Earth and its origins, Dr. Ruth didn't stop just with dry land. He also studied the depths of the oceans.
Commonly, it's stated that coral reefs disprove the Bible because it takes so long to grow some of these huge coral reefs that we have out in the Pacific. Well, I got interested in how fast do coral grow. It turns out that there are some coral that grow very fast. Some of them grow so fast you could build some of these huge reefs in less than 4,000 years. I received a phone call one day from a colleague of mine. I'd been doing research out in the Pacific. The Scripps Institute of Oceanography ship, the Alpha Helix, was there. And we were studying the metabolism of a coral reef there and so on. They knew me quite well there. And I was back here and working in my office, very busy, and I got a phone call. And one of the leaders of the Hydro Lab program, which was a laboratory underwater in the Bahamas, called me and said, "Don't you want to use the Hydro Lab for a week for your studies?" I told him, "No, I'm too busy." Well, he must have picked up some hesitation in me because he called me up a week later, and he said, "Have you changed your mind?" I said, "Okay, I'll try it. I'll try it." So myself, a couple of graduate students, we went and lived in this hydro lab for a week in the Bahamas. The National Oceanic and Atmospheric Administration was developing a program to expand man's outlook and man's ability to work in the ocean. And one of their projects was running the Hydro Lab, which is an underwater habitat, only 9 feet in diameter, 18 feet long. It has a door on it, which is on the bottom. You can understand why they put the door on the bottom, because it keeps air in, the air pressure in, and the ocean doesn't flow in. So you get in and out of it by going through this door in the bottom. They had 3 beds in there for us, and it's hard work, I'll tell you, when you live there, because every time you want to go out, you have to put on all this heavy equipment. We studied pigment, picture, temperature studies, living down there with the coral, studying how fast they grow, and studying this question of factors that might affect the rate of coral growth. 3 of us, we stayed there for a week, had a very enjoyable time, most wonderful experience in ways. I can remember once seeing a food chain in operation, a 3-inch abalone coming by the window in front. And then this abalone just came by, and a snapper came by and just snapped it. Just as the snapper was doing this, there was a grouper that used to live on top of the Hydro Lab. The grouper, he just grabbed the snapper. And this happened within about 10 seconds. One small fish eating a medium fish, a big fish eating the medium fish, and so on. Just one of the experiences we had there in the Hydro Lab. But when this man called me from National Oceanic and Atmospheric Administration about using the Hydro Lab, I told him, now you know, we will not work on Saturday. We're Seventh-day Adventists, and we respect that. Very well, we won't work. He said, "Yeah, we know you won't work. It's okay. You stay in the Hydro Lab. We go in on Tuesday. You can rest on Sabbath and go on with your work afterwards. Just fine." One of the questions that came up while we were there was, what if Christ's return occurred while we were down there? would we know about it? Another question was, well, supposing he returned, and would we have to decompress to get out of there? You have to decompress for about 16 hours. Would we have to decompress for 16 hours? Anyway, some of the side questions that come up during these issues. You know, we all have questions. I'm sure everybody wonders, does God exist? Is the Bible true? And I've had these questions all my life. I ask them all the time. The more I have studied nature, the more I've become convinced that the biblical model is the most reasonable model of how things came about. When I look at nature, I see design. I can't explain how life would originate by itself. I can't explain how the forces of physics could be so incredibly accurate. It just doesn't seem possible to me that this could happen by just pure chance. So my science tells me there's a designer. Our knowledge is not that great, but the challenges are not that great either. What if God exists? If you're looking for truth, you don't want to limit your horizon. You want to have as many possibilities so that in case one of them is true, you find it. Which is true? Are we just here for no purpose whatsoever? Or is there meaning to life? And is there goodness? We all aware of these things that you don't find by just studying matter. Our consciousness, our conscience, our love, our religion, our thinking, our reason, our creativity. This is not stuff you find in the simple materialistic approach to science. There's something beyond that.
The great thing about being a scientist is that you get to deal with mysteries on a daily basis. You want to know what's going on, and the effort that it takes to figure out anything is really impressive. I'm amazed by the effort that Dr. Roth has put into figuring things out, but that's what scientists do. I'm also impressed by the fact that Dr. Roth allowed his science to be informed by his biblical worldview. That worldview allowed him to see things that perhaps wouldn't have been observed by others. It allowed him to ask different questions, and as a consequence of that, we can have a more informed understanding of our Earth and its origins.
Okay, I think that was a really great video. You know, certainly, when we're in the midst of this lockdown, right? It's nice to be able to virtually see the Grand Canyon and also be able to virtually be underneath the water and to hear, yes, Ariel Roth talking about his experience, when he was examining, God's creation, and in essence, he found out that that the biblical account is what makes sense in terms of what it is that we are seeing right now. This was very good. Okay. So does anyone have any questions or comments?
I'd have to unmute yourself.
Oh, okay. You had to unmute yourself. Okay, yeah.
I would just like to say I think that Ariel Roth is one of the most insightful people I've met in my life. As a zoologist, he's got fantastic insights in geology. So I encourage people to go cross-discipline. I think it's good.
Yeah.
We had Ariel Roth speak at our group at least twice over the years, and it's been a joy to have him. He, like you say, he's an author, Ph.D. scientist, field researcher, professor. He just has a way of making it simple for you, even though he has such an in-depth understanding.
Mm-hmm.
Hi, Lisa. Hello. Yeah, I'm here. Oh, pretty good. Yeah, that's just Fandy and his wife talking.
Okay.
Hi, Mike.
Could you spell the name of the speaker in the video? Is it A-R-I-E-A-L first name or
A-R-I-E-L? Ariel.
And the last name?
Roth, R-O-T-H.
Oh, very good. Thank you. I picked up something that I don't know if the light is hitting it, but it's a track that we had at Rolling Hills Covenant. It's called Evidence of God by Lee Strobel. And one of the last points was the evidence of consciousness, and I heard the speaker Ariel talk about that.
Mm-hmm. Yeah, I interestingly enough, I first encountered that that issue from, I believe it was some Hare Krishnas or something. They're really into it in a big way. They've given this, well, of course, consciousness would be a big deal for Hindus, but they've really kind of hammered away on that one, which I can't say I fully understand what the motivation is if you believe that everything. Well, I guess they do believe that everything is a matter of consciousness. It's a physical reality is an illusion. So then it's consciousness you've got to account for. And
well, Jonathan Wells was a Hare Krishna that wrote Icons of Evolution. I think that's the pinnacle of what the Hare Krishnas have done. I think is through Jonathan Wells. That's an amazing book he wrote.
I thought he was a Mooney.
Yeah.
He was a Hare Krishna, I thought. No.
Yeah,
then I have that wrong. I was mistaken. I thought he was a Hare Krishna.
I'm not sure precisely what he is right now. I know that every once in a while we correspond about things, and it is a valuable thing to have people coming from different perspectives sometimes, but I'm pretty comfortable coming from a sort of biblical Christian perspective myself.
I got a couple of books by Ariel Roth. Actually, they're going to show you backwards. It's too bad. He's got one called Origins
and Science.
The Science Discovers God. I'll have to mirror image my video of myself, but Ariel Roth, amazing author and amazing PhD scientist.
He's still alive, he I believe someone said he was 94 now.
He doesn't teach anymore though, right?
No, but he, at least until very recently, he's been quite active. I obviously haven't seen him since the COVID thing started up, but he comes by my office every now and again. Always has some interesting insights and just a wonderful human being.
Yeah.
I always tease him about being French, and wanting to talk French with him. He refuses to do it.
I wanted to comment too about another Christian apologist and evangelist is in Southern California. He came from Australia, I think. It's Ray Comfort, and he uses the cosmology for creation science. He has a DVD that's also free on YouTube. It's called The Atheist Delusion.
Mhm.
And he shows a color book printed and four printed colors, and he asks, professors in universities, could this book just fall out of the sky and make itself? And then they have to blush and say no.
Right.
And that same logic doesn't hold water for their other theories.
Yeah. Very good. So, Dr. Standish, you have a PowerPoint for us tonight.
Yes. So shall we launch into it?
Why not?
All right, then. Well, this is, you guys are always such a fun group to be with. It seems to pity to cut off conversation. Will I be able to share my screen here? Somebody's going to have to make me a co-host or something to share my screen.
Garth, you're gonna do it, or I can do it, or
Change the host. Yeah, I'm going to make you a host. You should be a host now.
All right. So here we go. Let's see if I can now find. Okay, here we go. I'm going to start off with one of my favorite texts. I know that when it comes to the Bible, it's probably bad form to have. You know what? I'm going to actually try to get out of this just for a second, because I realize I left some timings in there, which will make it distracting as we go along. So I'm going to get in and turn off all of those timings, or it will be maddening for all of us. There we go. All right. Now we'll go ahead and get in. This is the beauty of technology. The instant you've got it under control, it will humble you. Here we go. All right, let's see if this works a little bit better. So, yeah, I know it's probably bad to have favorite authors in the Bible. For some reason or other, in the New Testament, I really enjoy Luke, and I really enjoy John. And one of the things that appeals to me about John is that he sounds so much like a scientist so much of the time. Here he is, he's writing to some people, and look at what he says. That which was from the beginning, which we have heard, which we have seen with our eyes, which we have looked upon and our hands have handled concerning the word of life. As a scientist, my profession is all about empirical data, what we take in through our senses, and then the logical interpretation of those data. And yet, as I mentioned earlier, we still find that we're very dependent on other people for our understanding, our knowledge of things. We simply cannot experience everything, so we have to rely on others. And for a very long time, I relied on what geologists were telling me. They kept telling me that there is overwhelming evidence that life is hundreds of millions, actually billions of years old, and therefore the Bible cannot be true. It was, frankly, a little bit disconcerting to me. So this particular presentation really came out of me going back to this text and a few others that are not dissimilar, that talk about direct empirical experience. I asked myself, what do I, as a biologist, see when I go and look at living things? Do they look like they're hundreds of millions or billions of years old? or do they look as if they are relatively recent? Now, obviously, we can't look at living things and see a copyright notice on there that says created by the Lord 4004 BC or something like that. That's not what we're going to see, but we should be able to very definitively differentiate between millions upon millions of years versus thousands of years as we look at things. It just makes a lot more sense to me if we are going to determine how old something is to actually look at that thing and not look at something else. And obviously geologists are, with all due respect, looking at something other than living things. So let's just lay out a few principles when it comes to science here. Number one, empirical data are the final word in science. So for better or for worse, it is not God's word that is the final word typically when we're talking about science. It's those data that we take in. So if we have a theory and the theory is incompatible with the data, at least in theory, that means our theory is wrong. It's never quite that simple, but data should be capable of testing theories. When it comes to interpretation, the further interpretation is from data, the greater the number of necessary assumptions involved, the greater the number of logical steps, the less certain the conclusion. And you've probably experienced this sort of thing before in your everyday life. If you see your mother walking out in the backyard, you are pretty sure that your mother is walking out in the backyard. But if you just see the door to the backyard being open, you might theorize that your mother has gone out through the back door into the yard, but it's a lot less certain than actually looking at her out there. And of course, the further away from there, let's say you see that the door to the backyard is closed, but you reason, well, my mother always closes the door when she goes out into the backyard, so therefore she's probably out in the backyard. Can you see how all of a sudden you are dealing with a theory that is pretty tenuous by that particular point? So the further we get away from direct data, direct observation, the less likely we are to be right. So again, it makes an awful lot of sense to look at living things if we're going to make a determination about how old they might be. And as I said, just to emphasize it again, empirical data are the final word. So it doesn't matter what theories say, data are king when it comes to science. Here are a few observations. Commonly, the logic used to infer long time periods requires multiple assumptions and logical steps. Therefore, if that second principle that I just presented to you is true, these are interpretations, these long time interpretations are less reliable than theories that are based on really direct observations. I mean, nobody is claiming to have directly observed the creation, except for God himself, of course. And he writes, he actually is an eyewitness, and he gives us an eyewitness account in at least the fourth commandment. So in any case, when we're looking at radiometric dating or other methods of dating things, there are logical steps. We're not directly observing the events, that we claim to be placing dates on. Direct observation of 6 biological phenomena indicate that life is not ancient. And by this, I mean millions or billions of years old. It does not prove that the Bible is true, but what we see are data that are consistent with the record of history in the Bible. I should mention one other thing. You know, the Bible is true. And when something is true, it is true irrespective of whether you can prove it. Which is kind of a difficult thing to, at least for me, to deal with sometimes. Because I want a really strong argument.
Excuse me for one moment, Dr. Standish. Philip, if you could mute everybody.
Okay, Dr. Standish, can you unmute? Okay, hold on. Clicking ask to unmute.
Okay, there we go.
Okay, good.
I'm unmuted. Another victory over technology. All right then. So let's take a look at these. What I'm really showing you is evidence that is consistent with what the Bible reveals to us. So first of all, the observed carbon-14 in the remains of organisms. We're going to go into each of these in just a little bit of detail. The observed fossil-associated molecular molecules that some of you probably have heard about. Observed mutation rates. Observed hybridization between many organisms. It's kind of some surprising stuff there. The interchangeability of parts. And again, this is probably something you haven't heard of before. And the sixth thing I'll include in there has to do with mitochondrial DNA. So we'll go through each of these. We'll try to unpack them just a little bit. But I want to illustrate what's going on here with this particular location. This is just south of Sydney in Australia. And probably many of you know that Australia is the Saudi Arabia of coal. There is an unbelievable amount of coal there. And you can see here, this is a place called Coal Cliff, one of the first coal seams that was discovered there. This particular one is overlain by a tremendous amount of sandstone. So why is this kind of interesting? Well, it captures my attention because there are 2 clocks going on here. Where this red line is a 5 million year gap. What that means is the coal is supposed to be 5 million years older than the overlying sandstone. And I don't know about you, but I know of nowhere on Earth where there's massive amounts of organic material that's building up on the bottom of the ocean or something like that in a really very flat kind of situation like this. So that isn't happening today. But in addition to that, the idea that you would have a layer of coal sitting on the Earth's surface, either out in the air or underwater, for 5 million years seems truly preposterous. Coal is not a hard material. It wears away. You've probably also heard that it's flammable. And sometimes things like coal catch on fire and they don't go out. This is the Bully coal seam, by the way. I'm trying to remember, it's hundreds of square kilometers. of this stuff. It's flat, and so it's a beautiful example of one of the things that Ariel Roth was pointing out, these paraconformities that we see all over the world. So what we have here when we look at this is two clocks. One of those clocks, the radiometric clock, basically says there is a 5 million year difference between the coal and the overlying sandstone. But if you want to call it the erosion clock here, tells us it cannot be 5 million years. So then the question becomes, well, which of these two clocks, when you're looking at it, which one do you believe? So at Coal Cliff, there are at least two clocks. There's the radiometric clock with the 5 million years. The flat interface between the layers indicates a short period of time. These flat gaps like this in the fossil record are called paraconformities, or the geologic record, and they're fairly common, as you probably picked up. This particular paraconformity that's visible there is 97,000 square miles. So this is a very, very big area. It's unimaginably big, frankly. This goes all around Sydney. It goes up to Newcastle in the north and down to Wollongong in the south. And here on the west coast, about 30% of the pollution that you experience actually comes from there. That coal is shipped up north to northern Asia, it's burned there, and the pollution then blows across here to the west coast. So I apologize, but there you go. Here's another picture of it. I mean, this is really amazing stuff. So the point that I'm trying to make here is there are different clocks. Everybody makes decisions about which clock they're going to believe. Let's talk a little bit about radiometric dating. There are lots of assumptions. There's the initial, we need to know the initial isotope concentrations. We assume we can do that, but we weren't there usually when these things occurred. In fact, I should tell you, and I better not say more about this because we're probably going to try to publish some of this material, but we took a sample a year or so ago of a known date and had it dated. It actually dated 250,000 years into the future. Obviously, we don't believe that date. Why would we believe that a similar date in the past? There are obviously some serious issues with radiometric dating, but I can't tell you really what they are. All I can tell you is it doesn't look to me, as someone who is not expert in the field but interested in it, it doesn't look to me like the kind of thing I'm ready to lose my faith over. It assumes constant isotope decay rates over time. It assumes that isotope decay is the only factor that alters relative concentrations of isotopes and their breakdown products. And there are probably some other assumptions and things that you can put in there. But here is the observation I would make. Radiometric dating commonly appears to work, but also commonly gives dates that no one believes. And when that happens, those dates are ignored. When the expected kind of dates are produced, they are treated as reliable. So it's kind of an interesting technique. I personally do not expect that radiometric dates would give dates older than a few thousand years for living things. And therefore, I believe that I'm in reasonably good company when I freely admit that where there are dates that are provided that are significantly older than that, I have my doubts about those dates. I love this clock. It hangs in my mother's house. And right now it gives the correct time twice a day. It usually isn't running, but I love this clock because my grandfather actually rescued it. There was a building at the hospital that he worked at in Australia, and this clock had hung in the lobby of that building for many years. And they were demolishing the building, and there was this clock tossed out onto the pile. And he went and saved it. And unfortunately, the face had been smashed. But he took it. The numerals, the Roman numerals that you see there on the face, he made those with X-ray film, cutting out pieces of X-ray film. He was such a clever man, my grandfather. So every time I see this clock, I think of him, but I don't expect that it's going to tell me the correct time when I look at it. Lots and lots of different ways of telling time. This is a water clock in Athens. You're familiar with sundials. Here is a clock at a university I visited in Africa. And have a look at those two dials. It actually had 4 dials on it. I believe all 4 of them were telling different times. And it wasn't the time in different parts of the world either. It just wasn't working properly. And as a consequence of that, even though it's a clock, probably a reasonably good clock, obviously, because it was giving multiple times, I didn't believe it. Yeah, there are 2 of the faces on the clock. So let's talk about examples of different times being provided, or different clocks providing times that do not fit, and specifically clocks that are appearing in living things. Okay, I'm using clock in a very metaphorical sense here. So we'll start off with carbon-14 and coal, and you'll remember that the ICR people have done some fabulous work with this stuff. Carbon-14 is generally recognized to be incapable of measuring ages beyond about 100,000 years. This is because carbon-14 breaks down too fast to provide reasonable accuracy. We used to say 50,000 years. Now people commonly say about 100,000 years. The point is, you are not going to be measuring millions of years using carbon-14 dating. It's not a reasonable expectation. So when you find carbon-14 in coal in measurable amounts, it either had carbon-14 put into it, or it is less than 100,000 years old. It's fascinating to me that I actually knew a guy who used to be head of the carbon-14 lab at UC Riverside. He went to my church, amazingly enough. And when he was confronted with these data, his immediate response was, well, it's contamination. So can you see that he was unwilling to believe his own clock when it gave dates that he was not willing to accept? He did not believe that life was recently created. And so, that was actually quite sobering to me. I was hoping that this, being presented with these data, would be something that would help this guy think about these things a little bit more clearly, but that wasn't what happened. Anyway, and I think now it's fairly well established that multiple coal samples that have produced carbon-14. It's been found in other organic materials also that are supposed to be, you know, in the 100 million year or even more range in terms of ages. But if the carbon-14 is there, the simplest, most logical explanation, from my perspective at least, is this stuff is not hundreds of millions or even millions of years old. It's not even hundreds of thousands of years old. So, yeah, diamonds, it's been found in. It's easy enough to dismiss it all as contamination, but after a while, do you really want to say that everything's contamination? If that's the case, if contamination is such a problem, how do you ever know that you have an accurate date? So here's a conclusion that we can draw from this. Different clocks give different ages for life. The radiometric clock sometimes indicates that life is thousands of years old, sometimes millions of years old. When it comes to carbon-14 in coal, that is a direct observation of something that I think we all believe was living material at one point in time. I personally think it's a very good indicator that this stuff is not millions of years old. People generally choose to believe the clocks that agree with their presuppositions. And there is no area that I've observed where this is more clearly demonstrated than in radiometric dating. So let's talk a little bit now about fossil-associated biological molecules. Here's the observation or the data. The following molecules have been found associated with fossils: proteins, polysaccharides, particularly things like cellulose, nucleic acids like DNA, unsaturated fats. This particular one is probably the most astonishing to me. If you know anything about chemistry, the idea that unsaturated fats are going to be hanging around for long periods of time is pretty extreme. So let's talk a little bit about protein, just to illustrate why it is surprising that we find these kinds of molecules still present in things that are supposed to be millions of years old. This is an amino acid, and there's the amine group on it. Here is the acid group. That's why they're called amino acids. And that R down there is kind of like an X in algebra. It could be anything. It just so happens that when it comes to the amino acids that the proteins that are found in living things are made out of, there are 20 different things that can be attached there. And that's why we talk about 20 different amino acids in living things. So when we bring two amino acids together, this is just two examples of a very, very, very simple amino acid called glycine. What you can see there is a hydrogen and a hydroxyl group. So if you count up the number of hydrogens, you can see there are two of them, and the number of oxygens, there's one. And if you put two hydrogens and an oxygen together, you get H2O. And so by removing a water molecule from these two amino acids, we can form what's called a peptide bond in this particular case. That's why you sometimes hear people talking about proteins as polypeptides. They are a long string of amino acids all joined together using these peptide bonds. Now, if we want to make proteins, we start making them by removing water molecules. These are called condensation reactions. But what if we want to break down amino acids, proteins? Well, if we want to unmake a protein, what we do is we bring in a water molecule and we insert it back into that peptide bond to break things apart. In fact, if you ate your supper, this is going on in your stomach right now. You have special machinery, little tiny molecular machines inside your stomach that are breaking down proteins by inserting water molecules like this. Hydrolysis is what this reaction is called. Now, this reaction occurs relatively slowly most of the time. But if you have the right machinery, you can speed it up very fast. The bottom line is this, though. It still happens without that machinery. It is a spontaneous reaction. And so if you put a protein into fairly ideal conditions, it will not last forever because it will break down just like this, and you will wind up with no protein left. And there are lots of other ways of breaking proteins as well. Things like radiation will break them apart. So major biological molecules other than proteins are also made by these condensation reactions. So polysaccharides, that's starch and cellulose, they're made by condensation reactions, removing a water molecule. Nucleic acids like DNA and RNA are made by condensation reactions, removing a water molecule. Triglycerides, that's fats and oils. Also, all of these, because they are made by removal of a water molecule, if water molecules are present, will break down. All spontaneously break down in the presence of water. It's very hard to find a place on Earth where there is absolutely zero water. Water is mostly everywhere. The driest place is probably the Atacama Desert. And even there, very occasionally, there's a bit of water that shows up. Where there's water, these molecules will not last for millions of years. So water breaks down proteins and these other biological molecules. They also oxidize. So if there's oxygen present, they will break down. There are lots of other chemical reactions that actually break them down. They can be physically broken. You can actually shear them. Yeah, radiation can break them down. If nothing else, background radiation should shred all of these very large molecules over enough time. So if you're invoking millions upon millions upon millions of years, these molecules are not going to be there anymore. And yet, some of you are probably familiar with this paper. This was kind of the first big one by Mary Schweitzer. And I remember when I first heard about it, actually, my colleague, Raul Esperante, walked into my office and he said, hey, next week, Mary Schweitzer is going to publish a paper in Science talking about soft tissues that she discovered in dinosaur bones. And I can quote myself. My exact words were, no, she isn't. It just seemed impossible to me that that would be happening. Now, incredibly, the next week, Mary Schweitzer actually gave a presentation in our building, and this paper came out. And obviously, I read this paper very carefully before I went into her presentation, and tried to keep a very skeptical perspective on it, because, you know, it's when you hear exactly what you want to hear, it's very easy to be fooled. That's how people get conned and things. And so I listened very carefully to her presentation, and I have to tell you, I was a lot more sympathetic to her position by the end than I had been at the beginning. I think this is real. In fact, I'm certain that it's real at this particular point because the ongoing research has borne it out. There is real soft tissue. This is pictures of the stuff that she found, down to the details that you can see here of cells and so on in there. This is the idea that this stuff is millions of years old is simply preposterous. And this is the actual T-Rex that it came from. This is, I hadn't realized it, but this is it. Sue, the T-Rex that's on display at the Field Museum in Chicago, is where the sample came from that she actually did this experiment on. So the objections to this have been pretty extreme, but they seem to have died down at this point because it's just fabulous data. It's true. It is what it appears to be. At least it looks that way. So some people have said this isn't protein from dinosaurs. It came from bacteria or fungus or something else. Iron preserves proteins. Well, anyway, hydroxyapatite, that's the calcium mineral, the calcium phosphate mineral that you find in making bones hard. Somehow or other preserves proteins. And, none of these things preserve proteins. Not for millions of years, they don't. That's for sure. And then, interestingly enough, earlier on, before the program started, we were talking a little bit about Mark Armitage and his work. This is the paper that got him basically fired from UC Santa Barbara, or at least no longer working there. It's a perfectly reasonable paper. It's a perfectly normal scientific paper talking about these soft sheets of basically horn material from Triceratops. And in this stuff, you are not seeing a whole lot of preservation by hydroxyapatite or a whole bunch of iron or anything like that. The bottom line is, as I've said, plenty and plenty of papers out there about this stuff now. It looks real. The arguments against its reality were essentially appeals to miracles, which is kind of an irony. So some conclusions that we can draw from this. All biological polymers are subject to degradation over time under any reasonably conceivable conditions. Rates of degradation have been measured. In fact, this has been done because there's a very good reason to do it. It's important when you're doing forensic work on bodies and things like that, to try to figure out how old a body is, how long it's been lying in a certain position, and so on. So explanations other than thousands rather than millions of years are appeals to miracles, not to science as it is currently understood. Very, very strong evidence of recent life, including dinosaurs and these other organisms where these things have been found. Let's talk about another line of evidence, mutations. And I want to give a lot of credit here to John Sanford. I'm not sure, he may have spoken there at some point. But if you ever have an opportunity to listen to John Sanford, it's well worth your time to do that. Mutations are undirected changes in an organism's DNA sequence. So they're considered to be random and undirected. Most mutations have a negative impact on fitness, so you don't want to be mutating if you can avoid it. The most common mutations are near neutral mutations, at least that's the way it seems. which have a very small negative impact on fitness. Now, this is important because they do have an impact, but that impact is too small for natural selection to act on. And that's a good thing because we'd all be dead if that was not the case. Our genetic systems are unbelievably robust, and it's as if they were designed to anticipate the kinds of challenges that our bodies are experiencing at the moment. Mutations that have a positive impact on fitness are rare, and they are still generally degradative mutations. It's not like new, novel, useful things are being invented in this process of mutation. So let's just take a look at what's going on here. When you do pedigrees, you usually symbolize females as a circle and males as a square. So here we have a male and a female, and they fall in love and get married, and they have a very good marriage, so they have 10 children. And let's imagine that just because, mutations happen, there is a mutation rate of 0.1 mutations per individual per generation. Now, let me just emphasize something to you here. Yes, I do know how to do statistics, and I do understand that the way I'm showing it to you here is not statistically correct, but it is illustrative. Okay, it's just so that you can get the point. That's just keep that in mind. So under these circumstances, we'd expect on average, let's say 0.1, 1 out of 10 of these children to have a mutation. And let's imagine that natural selection selects that individual out. And of course, everybody's very sad because that child is no longer around. They will not be making any grandchildren for our couple. But you know what? They can rejoice because 9 of their offspring will continue on, and they will have a happy family still. But let's imagine that there are 0.5 mutations per individual per generation. That would mean on average, let's say half of their children would be selected out. But at least they'd still have 5 left. Half would be left over. So this family would continue on into the future. But what would happen if the mutation rate was 1 mutations per individual per generation? This is where I'm doing a statistical crime, and I realize it, but this just illustrates the point, okay? Well, we might find that 100% of the children of this couple have a mutation, and if the mutation was lethal or made them sterile or something, there would be no grandchildren. There would just be this very sad couple growing old together. So what do you think the actual rate of mutation in human beings might be? Well, estimates vary, but the consensus is that humans experience more than 100 mutations per individual per generation. There is no possible way that natural selection could be weeding all of these out, because if it was, there would be no next generation. Now remember, near neutral mutations, which is what these things look like, they do not have a big enough impact for natural selection to act on, which is great, but they are still negative mutations. They are not positive mutations that are making our offspring more fit. So what these numbers suggest is that no children would survive if all negative mutations were eliminated by selection in each generation. We just couldn't do that. So therefore, mutations have to be passed on. Yeah, but most mutations are near neutral with just a small negative impact on fitness, thank God. Because they are not subject to selection, near neutral mutations accumulate in genomes. Because the measured human mutation rate is so high that all negative mutations cannot be eliminated by natural selection, humans are in something called error catastrophe, which if I was in a heavy metal rock band, that would be the name of it. Don't worry, I'm not thinking of giving up my current career. But anyway, the human genome is degenerating. Okay, that seems to be indisputable. But because much degeneration is near neutral mutations, and the genome was so robust in the first place, we survive to the present. However, this is the take-home lesson here. However, there is a limit to how long near neutral mutations can accumulate before fitness declines beyond the point that we can survive. So if there is a limit to how far we can go into the future, continuing to mutate at the current mutation rate, that means that there is a limit to how far back in the past the ancestor that we all shared lived. And it certainly doesn't look like that ancestor could have lived millions of years ago. Because if they'd lived millions of years ago, these mutations would have accumulated to the point that the humans would have died out. And by the way, so would everything else. So here's a conclusion. The high measured mutation rate in humans indicates that our genome is most likely degrading, and thus makes the contention that humans have existed for more than a few thousand years improbable. Let's call it overly optimistic. The same could be said for other organisms. This is really actually pretty strong evidence that life is not all that old. Certainly it can't be all that old and mutating the way it is right now. Here's a fourth category of data, if you want. Observed hybridization. There are a number of well-documented examples of speciation via hybridization. In fact, one of the big debates that Charles Darwin actually kind of was participating in had to do with how you get new species. There were people who believed that you got new species by hybridizing different species together to get a new variety, if you want. And there's lots of fuzziness in the language here. It gets very technical very fast. But if you look at people like the father of modern genetics, Gregor Mendel, it looks as if he was on the side of hybridization. And indisputably, in my mind, he had Darwin in his sights when he published his paper. I don't think that he really could have had him in his sights when he started his experiment, but this debate between slowly selecting things in a certain direction versus hybridizing to get different varieties was one that was going on at the time, and he clearly was wanting to participate in it. What we see in modern times are hybridizations that are, at least to me, surprising. And they should be surprising if you believe in long periods of time. A good example is the London plane tree, Platanus acerifolia. So this is an American plane tree or a sycamore. You've probably seen them. We don't have them too much here in Southern California, but out in the east. They're not an uncommon tree. They're actually a very attractive tree. So they grow in North America, generally towards the east. But there is another species, Platanus orientalis, that grows in the east. And you'll remember that a few hundred years ago, the English were sailing around the world and looking at all the different things that were there. They were getting rubber trees from South America and taking them to Malaysia so that they could have, developing rubber plantations there. That they were taking tea, I believe, to India, all sorts of stuff. They were moving plants around, and they were growing them in England at first, mainly in England, not so much in Wales or Scotland. But they were developing these big botanical gardens. So they took this American sycamore and this oriental plane tree that live more than 5,000 kilometers apart, so a great distance apart, and also should have been separated by probably something like 50 million years, according to the current understanding of things. And they happened to bring them together in the Oxford Botanical Gardens. And they were growing away there. And there's a story, I'm assuming it's true, that a gardener was working there and noticed these unusual saplings coming up. And the unusual saplings caught his attention, so they grew them. And lo and behold, the American sycamores and these oriental plane trees had hybridized with one another. What an extraordinary thing. I mean, an absolutely unbelievable thing if they'd been separated by 50 million years. I mean, think about it. If whales, according to evolutionary theory, evolved from some kind of wolf-like creature, it wasn't a wolf, it was kind of wolf-like creature, into, fully formed whales with fins and blowholes and all of those sorts of things in about 9 million years, how much changing and stuff should have occurred over 50 million years in these plants? Just drifting apart over 50 million years, you would think would make them incapable of interbreeding. Just amazing that you can bring together trees like that, unless they in fact are part of the same type or kind, and they happen to be growing in different areas. But you bring them back together after, a few hundred or a few thousand years, yeah, maybe there's a chance that they'll still be able to interbreed. Just absolutely unbelievable with 50 million years of separation, maybe believable with a few thousand years. Here's a picture. Let's see, where is this one? Anyway, this is a London plane tree. It might be in the Kew Gardens near London. Anyway, so here's a conclusion. If these two species, by the way, if you ever go to London, walk around and you'll see these London plane trees there, but you see them in big cities growing all over the world because they're very robust. They do well in big cities. They're kind of an attractive tree. So if these two species really have been separated by 50 million years of time, it seems remarkable that they can still interbreed, let alone produce offspring more tolerant of environmental challenges than either parent species. It seems more reasonable to conclude that they were not separated for eons of time. And this business of weird hybridization is not uncommon. hybridizations between things that are supposed to be separated by unbelievable periods of time, during which unbelievable amounts of change is supposed to have occurred in some organisms, but apparently not in these ones, according to evolutionary theory. Let's talk about interchangeable parts, because this is a really fun one. Sometimes parts from the molecular machines in one organism can be interchanged with parts from other organisms. This seems reasonable within similar species. So, for example, I don't know, maybe you could interchange some parts between rats and mice or something. I don't know. But remarkable. It seems remarkable when it occurs between very different species that are supposed to be separated by extraordinarily long time periods. So the example that I'm going to use is something called signal recognition particle. This is something that's kind of universal to life. I don't know of any organisms that don't have it. Bacteria have it, you have it, everything else has it, because it is an important component in the system that inserts proteins into membranes. It is made up of a piece of RNA with a number of different proteins attached to the RNA. And we don't need to go into any more detail really than that, but trust me, it's a really cool thing. Human signal recognition particle proteins form functional signal recognition particles when combined with the RNA component of Xenopus laevis, which is a frog. So in other words, you can take parts from frogs and parts from humans and put them together, and they fit together. Or from Drosophila, which is a kind of fly, you can do the same thing. It's jaw-dropping. This is kind of like saying, okay, I should be able to take parts from a Model T Ford and put them together, you know, if I need spare parts for my brand new Maserati. I don't have a brand new Maserati, by the way, but that's kind of the equivalent of what you're talking about here. You know, you can't interchange parts between a Maserati and a Model T Ford because they're not even metric. On the Model T Ford, at least I don't believe they are. So, yeah, I mean, this is just incredible. When are frogs and human beings supposed to have split ways? Or fruit flies and human beings? And yet, parts of our molecular machines are interchangeable. Wow. Replacing one major component of the dog signal recognition particle with the single large protein from E. coli, that's the bacteria that live in your gut, signal recognition particle, makes a signal recognition particle functional in all respects except for binding to the endoplasmic reticulum receptor, which makes an awful lot of sense because bacteria don't have endoplasmic reticulum. I cannot tell you how astonished I was when I started reading the papers on this. It's as if somebody went to Home Depot and built, I don't know, a school using materials from there and a house building materials from there, and you know, something went wrong in the school. So they go to the house and take a part out and stick it into the school because they're exactly the same parts, even though they're very different things. What it really, really, really doesn't look like is these things were, you know, evolving over millions and millions of years in completely different directions, and yet somehow or other maintained those super tight specifications necessary for these parts to be interchangeable. The corresponding dog signal recognition particle protein can bind to the RNA portion of E. coli or bacterial signal recognition particle. I mean, this is just unbelievable. And by the way, it's also worth mentioning that these parts share only 38% amino acid identity, which means they're not identical in sequence, but they are identical or very close in their shape and the way they function. Anyway, there are dramatic differences that exist, obviously, between dog and E. coli signal recognition particle RNAs as well. This is, I don't know, I do not know how to reasonably explain phenomena like this. And there are others that I could have listed, but I haven't, in terms of millions of years of evolution. So logical conclusion is that humans, frogs, and flies, interchangeable parts, are better explained by common design over a short time than common ancestry in hundreds of millions of years of evolution. It's very, very clear which is the more reasonable view in this particular case. This is even more true of dogs and bacteria, which are supposed to be separated by over 1 billion years of evolution. Number 6, and this will be the final one, mitochondrial DNA. So there's a paper that came out recently. It said that all life converges on a relatively recent date. That doesn't mean that all of life goes back to a single ancestor. In fact, it means something quite different. Mitochondria are usually inherited from mothers to their children. So if you looked at my mitochondria and you looked at my mother's mitochondria, you would find these are the little energy factories of cells. You would find a little circular piece of DNA in there. And that circular piece of DNA is called mitochondrial DNA. And if you compare the from my mother and my own, you should see that they would be identical. You do not get this particular little piece of DNA from your father, typically anyway. This mitochondrial DNA indicates that about 90% of organisms cluster into groups, maybe created kinds, that each descended from a single female, because remember, the mitochondrial DNA comes from the female line, estimated to live within the past 200,000 years. And you're probably looking at that and saying, well, just hang on a minute, 200,000 years is an awful lot longer than what the Bible suggests or records, I should say, in its history. But not only is this clustering consistent with a polyphyletic, in other words, multiple origins of life, or different groups, the time span is at least relatively recent. So you can see why this captured people's attention. Now, there is an alternative explanation. It's called coalescence. Over time, any population will probably end up with mitochondrial DNA derived from the same female. So imagine this situation. Here are a whole bunch of females, and the one that I'm showing you in red is going to be the one that actually passes its mitochondrial DNA onto everyone. This is what this phenomenon of coalescence is all about. So the one over here on the left, she has a daughter or daughters, and she passes on her mitochondrial DNA to them. Here's an individual who doesn't have any children for whatever reason. Here's one who has multiple daughters. And here's another one with a daughter. Here's another one who has none. Here is our one who is going to pass on hers to every generation. Everybody in the final generation. What you see by chance over time is a pattern where some lines die out and other lines continue on. Remember, we're just looking at mitochondrial DNA here. All of the other DNA could be being mixed among this population, but we wind up with everybody with it. This is something we would expect statistically over a long period of time. And this is the alternative explanation that's given. What isn't clear is that this will actually work, because you have to know an awful lot of things about population sizes and what's going on in populations and so on to really have a reasonable grip on this. But in any case, I just wanted to point out that for all of these things that I'm showing you, a Darwinist will have an alternative explanation. But what I'm hoping you're seeing is that there is a pattern here that is consistently and well explained from a biblical perspective. In fact, probably better explained from a biblical perspective. I want to draw your attention to this statement. It's from quite a few years ago now, but I remember reading it in Science magazine and being quite astonished. And this may help you feel a little bit more comfortable with that 200,000 year estimate on when all of these different groups of organisms seem to have had a single common female ancestor. This was in an article about the discovery of Tsar Nicholas II's remains. And it turned out that he has two populations of mitochondria in him, which is an unusual thing, but it does happen. It helped them to calibrate their mitochondrial clock for various technical reasons. So I'll just read this and let you be impressed. For example, researchers have calculated that the mitochondrial Eve, the woman whose mitochondrial DNA was ancestral to that in all living people, lived 100 to 200,000 years ago in Africa. Using the new clock, remember, now this is the calibrated clock based on observation, okay? She would be a mere 6,000 years old. And look how the next paragraph starts. No one thinks that's the case. But I do. But at what point should models switch from one mitochondrial DNA time zone to the other? Do not be surprised when you sometimes see numbers that conform to patterns that you're expecting, but not time spans that you're expecting. To me, this is just sort of a nice illustration of how these things work. Remember that people coming in with a very different perspective on things are not going to see that all of this fits so beautifully into biblical history. They have a completely different conception of history, and when what they're observing does not fit that, they do not accept what they are seeing. So in summary, multiple lines of evidence in living things and their preserved remains point toward thousands rather than millions of years of life on Earth. These include observed carbon-14 in the remains of organisms, observed fossil-associated biological molecules, observed mutation rates, observed hybridization, interchangeability of parts, and mitochondrial DNA. Evidence of short time for life requires interpretation, just like evidence of long ages. Evidence of a recent creation requires an equal number, or, this is really crucial, fewer assumptions and logical steps to interpret within a short biblical chronology than long Darwinian time periods. What I've been trying to present to you are actually simple arguments, not complicated arguments. There's what's supposed to be a Chinese proverb that says the equivalent. And by the way, I've never actually seen this in a Chinese thing, so whatever. That's why I'm calling it this, saying it's supposed to be a Chinese proverb. But whatever it is, I don't care who came up with it. It's a great one. It is, the longer the explanation, the bigger the lie. And these evidences that I've just presented to you require relatively short explanations. Thus, thousands of years of life is just as scientific, if not more scientific, than millions of years of life. Thanks so much for your attention. I don't know, did that make reasonable sense? Or was it too long and complicated?
Yes, yes. Yeah, we've actually covered a lot of that. So it was nice to hear a synopsis that overlapped, I'd say at least 90% from previous speakers. So it was really good. Thank you.
So I don't know, is somebody else talking about things like that, those interchangeable parts?
Not that
I didn't hear about that one.
Because that one I thought was pretty unique to me. I remember when it occurred to me. What?
The first thought in my mind about interchangeable parts that you were mentioning, I was thinking, well, that might not be a good argument because the DNA is pretty much based on the same bases. And I got to thinking, no, you're not talking about just the DNA helical structure. You're talking about proteins, which is massive amounts beyond that. It's
and the fact that we're talking about lots of different molecular machines, and the fact that they maintain those amazing tolerances that they have to have as an organism. As you go from a bacterium to a dog, the machines don't change, but the entire body of the thing changes. That's just a pretty preposterous proposition that, no matter what kind of time span you're talking about. But obviously, if you have common design and there have not been eons of time for these things to simply drift apart, then maybe you will still have interchangeable stuff. I'll tell you one more that took my breath away, and I can thank Stephen Jay Gould for this, of all people. Years ago, he wrote a book called Hen's Teeth and Horse's Toes, and in there he talks about these experiments that were done that supposedly produced teeth in chickens. They didn't. They produced structures that were interpreted as possibly being tooth buds. Big, totally different thing from actual teeth. But if you look at it in the popular media, they have pictures of chickens with teeth in there. Excuse me. But basically what they did was they took these special embryonic cells that are going to turn in or play a role in tooth production. They took them from a mouse embryo and put them into a chick embryo. And lo and behold, what happened was, and this actually did happen, these cells start out here sort of behind the neck in this embryo. It obviously isn't exactly a neck. And they migrate around and down into the jaw, into specific locations there. When those special cells, we'll call them, come into contact with the lining of the mouth, okay, there are signals that are passed back and forth between those, and the tissues inside the mouth actually start producing the enamel, this is in a normal situation, the enamel and the tissues that came from back up here and down into the jaw, they start producing dentin. That's why we have teeth that have this outer layer of enamel and dentin inside. Things didn't get anything like that far along in the chick embryos. But what did happen was those mouse cells were able to migrate accurately down into the positions that they would normally occupy in a mouse embryo. I was just blown away by that. You know, according to evolutionary theory, we're talking about organisms there that split well over 100 million years ago. And yet the molecular signals that can be recognized by these two organisms, very different cells, can be recognized, and that migration can happen. I mean, they've got totally different kinds of mouths.
Yeah.
You know, why would you expect that from a Darwinian perspective? You know, a common design perspective, that's understandable. But from a Darwinian perspective, it's you know, you just you sort of, it's funny because Gould was arguing, proof basically that you can get, you know, that birds once had teeth in their mouths, and they still have this latent capacity, which was not shown by the experiment, which is a pity. By the way, I mean, I don't know. I'm not sure it would destroy my faith if you could induce tooth production in birds, but
some ancient birds have teeth anyway.
Yes, yeah. You know, there's you know, in the past, birds obviously had far greater diversity than they have in the present, which makes them like, it seems like many other groups of organisms. You know, greater diversity among mammals. The pattern that you see in birds and many other groups is greater diversity appearing first and less diversity afterwards, which again is the opposite of the Darwinian pattern, the evolutionary pattern that you would expect, if you embrace that particular way of thinking anyway.
Gene pool should be getting more robust. It should have more different types of expressions that never existed before, and that's not what we're seeing. We see old expressions that we don't ever see anymore, and fewer expressions of genetics.
Yeah, we should see novelty appearing over time.
Right.
From a molecular perspective, I don't want to, you know, I hate to use universal language because somebody's going to come up with something somewhere that they say is the exception that disproves it or whatever. But I don't know of any actual example of any molecular novelty that has been, you know, sort of genuinely demonstrated to have appeared over time. Certainly at the molecular level. Now, people do argue, well, look at this. I see wings on birds here in the Cretaceous, maybe in the upper Jurassic. So therefore, that's a morphological novelty. And there's an interesting mix of things going on there. I think I've talked with you guys before about bird evolution.
Yeah, talked on Archaeopteryx and bird evolution, both.
Yeah, okay. But at the end of the day, molecular stuff, no. In fact, the molecular stuff seems to appear instantaneously when you see life appearing. And life, well, evidence of life, particularly evidence of photosynthesis, seems to be evident in the oldest rocks available, which has been something that's been quite a surprise to me. Apparently, and again, you want to be careful about it. Lots of steps of reasoning, but basically, when photosynthesis, takes carbon dioxide out of the air and turns it into sugar by combining it with water, releasing oxygen. When that happens, there is a distinctive ratio of carbon-13, okay, not carbon-14, carbon-13, which is a stable isotope of carbon, and carbon-12. So you can look at that carbon-13, carbon-12 ratio and tell when something is a product of photosynthesis. And what they found is in zircons, small bits of graphite that have that distinctive carbon-12, carbon-13 ratio, and they're dating them to somewhere between 3.8 and I think 4.2 billion years old, which is pretty much the instant there's supposed to be a crust on the surface of the Earth, according to the current model for how things. There are not billions of years for life to come into existence. So I want to be careful about it, but I think that most reasonable people should at this particular point be saying, okay, we've got to look at some model other than life evolving here on Earth. They're just, you could argue that life somehow or other, it just spontaneously comes into existence under certain circumstances that happened to exist as soon as there was a crust on the Earth, which seems like a pretty tenuous argument. You could argue for the sort of panspermia idea that life came from outer space, somehow or other on asteroids or something. Or you could argue for, biblical creation. But I know that there are people who are still looking for ways to keep the idea of life evolving on, life itself coming into existence on the Earth's surface. But wow, it is not getting easier to hold that position, is how I'd put it.
Yes. Does anybody else have any questions for Dr. Standish? Phil, you want to throw a zinger in there for us?
A zinger? Well, actually, I do have a question as it relates to the mitochondrial, the mitochondria, right? And so, yes, I too have actually heard about this, the concept of mitochondrial Eve, and that's certainly very exciting. It's been a while since I looked at that stuff, but I was wondering, is it true that there's evidence that, like, if someone tried to, I guess, how do you say it? If you had a sample of someone's cell or something like that, right? And you examine the mitochondria, right? Like, you could trace it, like anyone in the world, right? You just take a look, right? That it could be traced back to like 3 particular females, that being the wives of Shem, Ham, and Japheth, the sons of Noah?
The simple answer, but I'm a little bit scared to say it because it's also a little bit simplistic, but the simple answer is yes. You can do similar things with Y chromosomes and trace back to, basically to Noah himself. So the situation with Shem, Ham, and Japheth and their wives, the Y chromosomes is relatively simple and straightforward because Shem, Ham, and Japheth all have Noah's Y chromosome. So you should be able to kind of converge on something fairly simply. Mitochondrial DNA is a little bit more complex of a situation because there is some evidence that you get recombination in there sometimes. So while I would say most of the time, the mitochondria pass down from mother to child, it doesn't matter whether it's a male or a female child, I'm a little bit unnerved because there is this, what I consider to be pretty good evidence that there is occasionally some kind of recombination that happens. In addition to that, you occasionally get these individuals who have two populations. They obviously don't have two mothers. So that's a little bit strange, what's going on there. My gut feeling is, okay, but I'm not going to claim to this is the gospel truth, okay? But my gut feeling is that generally speaking, what those things do is compress time. Because to develop novel new things in mitochondria should take less time if you have occasional recombination going on. So my belief is that probably the mitochondrial clock is off, and as a consequence of that, the 100 to 200,000 year thing is probably wrong. There are other reasons to think that. You know, if you just start doing the math, you kind of find out that we all share common ancestors in the relatively recent past. So these things get pretty complex. You just think about it like this. I have a mother and a father, so I have two parents. Each of them has two parents. So I have 4 grandparents. I've got 8 great-grandparents. I've got 16 great-great-grandparents, and so on. And what that means is that after a relatively small number of generations, you get back to the point where you have more ancestors than there are thought to be people on Earth. And so we all have to be related through those people somehow or other. Mathematically, it's very likely that, I mean, what are the alternatives? So when you get into these things, it's a little bit easy to kind of go shooting off probably what I would call a little bit too confidently about them, because there are certain mathematical realities that say we've got to converge on a common ancestor. There was a paper that came out, and I've got to say it's got to be probably at least 20 years ago now, and I believe it was in Nature, where they'd actually modeled this. They'd taken into consideration things like immigration rates and those sorts of things, migration around the world and stuff, to the best of their knowledge going back in time. And what they predicted in their model anyway was that every single human being shares at least one common ancestor from around the time of Christ. Okay, that doesn't mean a single common ancestor. So you and I, Philip, might have a common ancestor. Let's call him Fred. And Garth and I might have a common ancestor, but that might be Judith. You know, totally different people, not married to each other or even knowing each other. But that's what that means around the time of Christ, about 2,000 years ago. But it's very, very recent, shockingly recent. But then it looks like we should be able to again, according to these guys, trace things back to something on the order of 4,000 to 6,000 years, as I recall it, which was disturbing to me, because if it's mathematically got to be that way, then how do you test it? You know, on the one hand, it kind of makes me excited to see this sort of thing. But on the other hand, you really have to think about them a bit before you start getting too excited about them. I'll tell you one thing that I was excited about some years ago, and I haven't seen any reason not to be, and that is that when they went after mitochondrial Eve, they said she was about 100,000 years or 200,000 years ago, and then they said, well, why Adam was something like 60,000 years ago, or a range in there. And I still remember seeing a popular article about it, basically saying, ha ha ha, Adam and Eve didn't live at the same time. But I was astonished, because it was exactly the pattern that you would expect to see if Bible history is true. You have 4 different populations of 4 different mitochondrial DNAs on the ark: Mrs. Noah, and then Mrs. Shem, and Mrs. Right? You've only got one Y chromosome on the ark, the Noah one. So you would expect, because of that greater diversity on the ark of the mitochondrial DNA, that to trace back to the common ancestor of all those mitochondrial DNAs would go back further in time, in fact, another 2,000 years or thereabouts. So I would put that in the category of, wow, that's a really nice pattern. It's consistent with the Bible, but the scale I'd have a problem with. And these things are not that uncommon.
Yeah.
Have any of you guys seen that Patterns of Evidence video about the Exodus?
Yeah, I just watched it recently.
Yeah, I just watched it yesterday, and I was intrigued by it. I thought that guy took a kind of nice approach to it all, but in some ways, I feel like we're in the same boat with some things, particularly as it relates to time. It's ironic to me that time is that wedge that is used all the time to get in between people and their faith in God's word. And yet time is the most ephemeral thing out there. As a biologist, to me, the question of design in living things is you know, I mean, to argue against it is to have the data as your enemy. Even if you believe in common ancestry and everything, you're kicking against the pricks. That's how I would put it, to argue against design. So in my mind, you know, as a biologist, I have a tendency to say, okay, the firm answer is living things are designed. The not so firm answer is life is hundreds of millions of years old or billions of years old, whatever you want to go with. But if life is designed, that means there's been intervention, and I don't know what was going on in the past completely. I have to have faith in the record that I'm given, because science is not going to work perfectly with this. It's like, you know, it's like showing up, you know, having lived my entire life in a valley in New Guinea where people never go out of the valley, showing up in my front yard and looking at the car and trying to come up with a naturalistic explanation for it. That's what I would say we as scientists are doing when we're looking at living things. Time, it travels in one direction. We can't go back. We can't study any of that stuff in the present. And as a consequence of that, the answer simply cannot be as definitive.
Yes.
So the way I see it is, people are losing their faith over the thing that is least knowable.
Amen.
When your faith can be built on what is most knowable.
Yeah. Amen.
How I put it. Yeah.
Amen.
Anyway, I love this stuff. As you can tell, I could talk about it all night long. But I worry that you know, there's only so much. I thank God I wound up doing what I'm doing. I can't believe that he led in this way. I didn't deserve it. You know, I wasn't spending all the time on my knees that I should have been spending, you know, pleading with him to lead in my life, and yet he did.
Yeah.
Just amazing.
Yeah.
And yeah, every day there's something that comes across my desk on my computer now that takes my breath away.
I really think that time and chance are the two idols of our culture. Chance is not an entity, it's an absence of intelligence, right? Chance means nothing. Time is not an entity. You cannot capture time. You cannot, you know, measure 10 grams of time, something like that. It's not something that's measurable. And yet the great illusion that, you know, people like Charles Lyell brought into the world was that time is subject to scientific inquiry in the same sense that empirical study is in the present world. And that's a complete fallacy. Really, really, really bad. And I'm with you that that people do not trip over people tend to trip over the things that are the most obscure. They forget about the things that are most readily apprehended, right?
Exactly. You know, the devil is a genius
Yes.
at undermining our faith with air. It's incredible. And by the way, I'm not pointing at other people. I'm saying myself. Sometimes I find myself struggling with things. I want answers to every question. I want, I want to go out there and convince everybody for Christ. Don't we all want to do that? We see through a glass darkly, no doubt about that. But wow, what is clear is really clear. And there almost nothing that you hear that Confucius said was actually said by Confucius. A few years ago, I decided it was time for me to read Confucius. So I sat down and I read the Analects. And it was an interesting read, but there were very few really deep thoughts that I got out of it. One of them, though, was really great. He said, and I'm paraphrasing here, basically, let me tell you what knowledge is. Knowledge is to know what you know and to know what you don't know. That is true knowledge. And what I've realized about Christianity, biblical Christianity, is that it liberates us to understand when we don't know things. There will always be times that we will live by faith, not understanding everything. But if we do that, we understand that's what we're doing. We understand that we don't have the answer to something. But imagine being in the position of that I observe many of my Darwinist friends in, where they feel like they have to have the answer to everything, no matter how ridiculous. For some reason or other, faith is unacceptable. I could respect it a lot better if they would say, I don't have the answer to that, but I have faith that the answer exists. Then we can be operating, then we know where we're operating, what the space is. But instead, what's offered are explanations that are obviously wrong. And probably the thing that I would urge for all of us is, let's be sure we don't do that. Let's carefully think through the witness that we're giving for Christ. And that doesn't mean we're going to be right 100% of the time when we're talking about the details of things out there. But it's okay to say, I don't know this, but I do know this. And I suspect that for many people, that will be a much more powerful witness than trying to provide inadequate answers to questions.
Well, as I recall, there's two kinds of knowledge. And it's nice to have it spelled out so you don't have the wool pulled over your eyes. The first is what you've been talking about tonight, observable knowledge, observable things that you can test and experiment on. And then we call that empirical, scientific knowledge. But that's not the only scientific knowledge. There's also the things that happened in the past that were written down by eyewitnesses that were there, and that's called historical scientific knowledge. So there's two kinds of science. One's historical by people that were there, and the other is the here and now that you can observe. And scientists that we call scientists tend to be those that do the experiments in the here and now. And they never like to really admit that there's an area of science that they may not be experts on, and that's the stuff that happened in the past that was recorded. To that, a lot of that is anomalous to them. They can't figure it out, and so they try to explain it away. So if you hear that Christ rose from the dead and it's a miracle, that can't be true. They believe that, they hear that the universe was created in 6 days and then it was miraculous. Well, that can't be true. So they try to explain it away. And evolution is nothing more than all those frivolous explanations to that. What do you do about a universe that doesn't have a God? How do you make a universe like that? Well, it'd have to be some bad explanation that is obviously not true, but they couldn't make it as palatable as possible to explain away the history by those that were there and wrote it down for us, namely God and Moses and the other biblical authors.
You know, the incredible thing to me about Christianity is that there are obviously things that are unknowable. I mean, God is infinite. God is omniscient. God's omnipotent. God is spirit. All of these things, you know, if we're honest with ourselves, those are, you know, God is beyond our comprehension. There's no doubt about that. And yet, God, you know, the creator of all things, came down to earth. He became one of us. He lived among us. He demonstrated his power. He showed that when he said, I can, you know, I'm going to raise you all from the dead, he showed that he could do that. You know, in Revelation, see, I'm trying to remember 21 verse 5. I'm going to make a new creation. I'm making all things new. Why can we believe that? Because he's done it. He is the creator in the first place. So we can believe it. That's the God of the Bible. I believe myself that everybody worships whatever they think their creator is. It's just a natural urge that human beings seem to have. The creator in the Darwinian thing is always placed beyond observation, inevitably placed beyond observation. There are all sorts of things that can't be observed: dark matter, dark energy, parallel universes, things put, you know, so far back in time that there were no witnesses to observe the evolution of, I don't know, fish into amphibians or something. All of those things, everything, you know, time is used to place things beyond observation. Space is used to place things beyond. It's always beyond observation, and yet spoken of with absolute certainty. I compare that with, you know, Jesus Christ. I mean, it's, what better option could there possibly be out there than the creator coming and being one of us? And yet we're the ones who are comfortable with living by faith, and these guys claim to be, you know, living by sight, if you want to call it that way. But they're never seeing, you know, the magic always happens just out of view.
Yeah, absolutely.
I think there were scientists who made quotes that said something like, and I'm paraphrasing, I don't have one, You say, give me an alternative to this ridiculous theory of evolution and I'll take it. But I don't want the one that says that God did it.
Mm-hmm.
Because that's just unthinkable, they say. And I like what somebody said, that if it's unthinkable, that's because you can't think, that's all. But it is true. Man must have his creation myth, doesn't he?
Yeah.
He must have a story. He must have an alternative to in the beginning God created. Because that's the nature of man. He's running from God. Yeah.
Reminds me of the title of A.E. Wilder Smith's book,
Yeah.
He Has to Believe. So
That's
obviously
who
you're not willing to think.
yeah. I'm glad you noticed that, Garth, because that's who I was referring to, was Wilder Smith.
Oh, okay.
Yeah.
Yeah. Well, it's a good time in history to be a Christian.
Yeah.
Yeah. I know it's easy to look around and get discouraged. I mean, so much stuff is going on in the world. I fear for Western civilization right now. But, you know, it's, I mean, like I said, every week in the science journals, there is something else that just makes you go, wow, yeah, God is great. Things that you say, man, I never would have imagined that. It's a little bit like, probably all of you have had an experience something like this. And Bill, I'm sure you did, but everybody in their lives, probably it's a bit like this. I remember when I took biology in high school, and at the end of it, I thought, oh, I kind of understood that. Particularly the Krebs cycle. I thought, yeah, that was pretty complicated, but I think I understood it. And then I took, Foundations of Biology, it was called in university. Oh, it turned out that biochemical pathway was a bit more interesting than I'd appreciated, a little bit more challenging. And at the end of it, I thought, wow, I'm not sure I really understand that. And then, I ultimately took biochemistry, and that was really unnerving because I worked very hard and realized I didn't understand it. I definitely did. It wasn't a matter of I might not understand this. I knew I didn't understand it.
Wow.
So I took some other classes along those lines. Eventually I was doing my Ph.D. and I thought, now is the time to do it. And it wasn't just the Krebs cycle. I was really bothered by photosynthesis, because as you probably know, in all of these classes, they go over photosynthesis fairly lightly, and you realize, whoa, you know what? There's some skimming going on here. I'm not getting this, and maybe this reveals how neurotic I am, but I thought I want to go and teach at a university. I've got to understand this stuff. I will not let this final opportunity to understand this. I'm not going to be the only fool who doesn't understand this stuff, basically, right? So I took this fabulous, basically very advanced biochemistry class. And I did things that were not required at all by the class. I actually balanced the Krebs cycle. Trust me, you don't know anybody else who's done that. And It was an act of insanity. But you can balance it. You can balance it. And I had two experiences that came out of that. One was the realization, I'm never going to understand this. I am never going to truly understand this, because the more I get into it, the more phenomenal this is. And it was almost like I still remember the moment this happened. It was like I imagine it is for prophets to have visions and things. Don't get me wrong, I don't think I was having visions, but I imagine it was just sort of this epiphany about this thing. Can't really explain it. It's like seeing something, an exquisitely beautiful work of art. It was really the moment that I got the dynamic model working in my head, so that I wasn't looking at, okay, this individual step, this individual thing is happening. It was a little bit of comprehension of the molecular machinery involved and the dynamic nature of it. Absolutely phenomenal. And you know what? I think about Ecclesiastes 3:11, which is where Solomon says, you know, the bit about God, everything has made everything beautiful in his time. He goes on from that. We have a tendency just to sort of quote that little phrase out of there. He goes on and he said, but he's put eternity in the heart of man, but will never know the end from the beginning. And I can't help but tell you that makes me so excited about heaven. Yeah, eternity, it's never going to run out. It's always going to be amazing. There's always going to be more to learn, and the reward of learning that thing is always going to be exquisite. I'm sure the same thing is true with geology. I'm sure it's true with absolutely every other area of study and knowledge that's available out there. You know, it makes me so excited. You know, and grateful that God has you know, won our salvation. We're going to be there. We're going to be there, and we're going to be doing that. Yeah. So hopefully we can be studying these things together.
I got to say, I can marvel at a hummingbird a lot more than I can marvel at, you know, the uranium lead dating. Something. I'm with you on that.
Yeah. It's true, but
there's something about biology that's different, huh?
It's unfair, isn't it? Yeah. You guys wandering around in deserts all the time.
Yeah.
Geology has its beauty and wonder as well. You know, I greatly enjoy going out with my friends, and yes, I will admit I'm more often than not looking at the tracks that you can see in the desert and thinking about the organisms that are out there and marveling at the fact that there are plants that can survive under these circumstances and all of those things. But wow, you know, the Grand Canyon at sunrise, what an amazing thing. You saw me in that film freezing to death, I might add.
Oh.
It was about 8 degrees.
Oh.
It was savage. It was absolutely savage.
Oh.
Yeah.
You know, my wife and I went to the Grand Canyon for our honeymoon, and we actually slept in a tent at 5 degrees.
Oh, yes, but at least you had your wife.
We didn't think that one through.
You did well in the video, though. It looked good.
Yeah, that was I think the second one that we did, and I got to give a huge amount of credit to there's this guy I work with named Greg Battler, just a fabulous guy, and we've had many adventures together now.
Is that video series available on the web?
Yeah, it's
I
I'm
can
trying to
find it.
remember how many we've got up now, but we'll keep working on them. I'll tell you quite honestly, the first one I did was the one of on Harold Coffin, and I can't remember what it was that really got me thinking, but I was always so impressed by his story, and by him personally. He went to the same school I went to in Singapore, which is kind of cool, and so I didn't really know him, but I'd heard him speak and stuff. And I guess I'd probably just seen him speak or something and thought, he's not going to be around forever. And we should make a record of this. So I managed to get some money, and I went and did it. And it worked out well. And I thought, well, this is something that would be worth continuing doing. So I try to do one or two a year.
Nice.
Fortunately, that's all the time and money I can get to do it. But I think they're getting better, every one of them, and I've certainly met some fabulous people. There's this, there's this guy who's professor of chemistry at St Andrews University in Scotland, which is probably the most prestigious university in Scotland. That's where Prince William went. Fabulous place, incredible Reformation history there, with John Knox and everything. But this guy's an absolute genius, and so it was fun to do him. And then he introduced me to this Portuguese woman who has an incredible story as well. So we did one on her. And it's gone on, but they're all there on the GRI webpage. And welcome to you. In fact, Bill, if you send me an email so that I have your email address, I would any of the stuff we have, use in any way that you see as useful.
Thank you.
And but I would ask this: as you go along, if you see errors and stuff or whatever, just let us know. Yeah. If we can fix things, obviously that's what we want to do. I wish that perfection was attainable here on Earth.
Oh yeah.
And any project you work away with.
I always appreciate how I found that the people I've come across with GRI and Harold Coffin had a big impact on me. I read his book Origin by Design a long time ago. Wonderful book, really lucid, really a great read. I devoured that thing.
Yeah, I can kind of trace back my interest in this to him indirectly. And I think I talk about this in the film about him, but I was going to school in Singapore. I believe it was my freshman year. And this guy showed up, some American guy, and the teacher invited him into our biology class. And he talked about the Specimen Creek and some of the research they were doing there. I had no idea who he was, but I'm almost certain now that it was Mike Arndt, and I don't know if you know him or whatever. It doesn't really matter.
I know about him. I know his work. Yeah.
So what on earth he was doing in Singapore, I don't know, but it interested me at the time.
what I was going to say is I've always appreciated how that people like Ariel Roth, Harold Coffin, yourself, and others, I've noticed you've got a very good way of always being careful to understate your case and trying to be careful never to overstate, right? Which is very easy to do, especially when you're talking to lay people, right? It's easy to overgeneralize and overstate your case, and it's a temptation.
Yeah. Well, it's a disturbing. It was a disturbing realization to me that you can bamboozle any audience
Yeah.
whom you know with the expertise that you have.
Yeah.
And as Christians, we don't want to do that.
Yeah.
We want people to have a solid, reasonable understanding of what's going on, and to be open and honest about what we do know and what we don't know, and how we think we know it.
Yeah.
You know, I hope that it's been very plain that I have absolute faith in God's word. You know, at the same time, you know, I'm actually one of those people who hopes that God doesn't give us all the answers immediately when we get to heaven. I'd like to, I'd like to spend some time working on these puzzles to see how far we can get. But there's probably going to come a point where we're going to have to ask for a hint or two. That's my suspicion.
I think there's going to be teaching in heaven.
Mm-hmm.
Yeah. It's very exciting to think about.
It is. Yeah. Well, if you like learning. But learning is an exercise in humility. You learned what you thought you knew wasn't right, commonly, and I commonly try to draw the attention of my students to that.
Mm.
And you know, I'm sure that you could give examples of it. Certainly, plenty of examples. Stuff that I taught, believing it to be true, has turned out to be obviously wrong. Now, I'm actually at that point in my life where I'm discovering that I have taught people complete falsehoods, and in retrospect, I should have seen it. But it's so much easier in retrospect than at the time. You believe what is in the textbook. You believe what you hear other people, you know, your professors have told you, and it's you know, well, for better or for worse, let's put it that way. You'd better maintain a spirit of humility in any of these disciplines. Garth, you're a fireman, right?
Yes.
Yeah. Well, I mean, surely you have to do exactly the same thing. I mean, if you're not humble in front of that fire, I imagine that you're probably going to get pretty badly burned at some point.
Yeah, we have to follow the rules, and we have to maintain our safety procedures, wear our protective gear, or that fire will dominate us. But with the right conditions and the right tools, doing the right thing, we dominate the fire. That's why we go there. That's why we're not afraid of it. But we have a healthy respect for it. That's for sure.
Yeah.
I'm going to put this on the. Oh, I got it backwards again.
No, it's fine. At least on my screen, I can see it perfectly.
Yeah, on my screen too.
Oh, well, good. So what I'm going to do is this will be on the Facebook page, and you guys can use it for review. And we need to close in prayer now, but we can continue after. For those that want to stay and talk, that's fine. But for those that need to go, this will be a good time. Oh, yeah. We just had the Feast of Trumpets. My wife's asking me to do the shofar right now. Maybe afterwards. Let's close in prayer. Heavenly Father, we ask for you to bless what we've heard. Help us to make it a part of our personal apologetics and helping others to understand who you are and what you've done. And Lord, we ask for you to bless our country. We ask for you to bless the new Supreme Court nominee. May she be very biblically and constitutionally friendly. We thank you for the opportunity that we have to pray and intercede on behalf of our country. We ask for you to bless Dr. Standish and Bill Hosch, and may their ministries thrive. May the numbers of people that reach intensify and grow. We ask for you to bless this ministry of South Bay Creation Science Association to grow also in numbers. And we thank you for the quality of the messages that are being brought forth and the men and women that are bringing them forth. We ask your blessings on them all. We ask your blessings on everyone, our members that are here and that are not here. And may they be effective in communicating who you are and what you've done, and be effective in discipling. Help us to have lasting fruit, and help us to make disciples that make disciples, because it's really not making a disciple unless that happens. So Lord, we ask for you to give us that life-giving capability. Communicate the life that you have shown to us on the cross and in the resurrection and in the ascension and in the intercession that you're doing right now in heaven for us, waiting for us until the second coming. Lord, we bless your holy name. We ask you to bless all this time and the seeds that were planted and watered in Jesus' name. Amen. So if you want to be tortured, I do have a real shofar that I wouldn't mind showing.
Let's see it.
About a 40-inch kudu kosher shofar, and barely know how to play it, so we'll see how I can do this stuff. I'll just do a very basic blow here. It's really bad tonight, guys. Okay, thank you for letting me torture you.
Hey, I'm sure you were better than I'd be.
Dr. Standish, I didn't know you were speaking tonight, and so it was a great refreshment to hear you. And I'm sorry I had to cut out in the middle of it, but it was what I heard was really good. Appreciate it.
It's a pleasure to meet you. I don't think that we've ever met before in person.
We did meet once before briefly. I remember visiting the Institute there, and I met you, and we chatted for about 60 seconds, I think, and then moved on. Yeah.
Well, come by again sometime. You're always welcome.
Thank you.
Of course, right now isn't a very good time because we're supposed to be working at home mostly.
Yeah.
It's going to be nice when COVID is lifted and all you guys can come and we can see you in person in the future.
Yeah, me too. Yeah. But maybe I can get your email from Philip, perhaps, and we can exchange email, because I'd love to get your textbook if I could.
Yeah,
biology textbook. I know some young people that might be impacted by your biology textbook.
Oh, wonderful. Yeah. And by the way, that's I may already have said it, but that's another sort of thing. As if you see errors in it, if you see something that you wish was done better, please do let me know. I can tell you that now that I've done a textbook, I understand completely why textbooks are full of nonsense and errors. It's exasperating.
Bet. Yeah.
Tedious work, huh?
It is. The actual writing side of things isn't bad. It's hard work, but it's the dealing with editors, dealing with the publisher, and those sorts of things nearly drives you to the edge of sanity. So, for example, and by the way, this is not a specific criticism of the people necessarily at Kendall Hunt. It's the nature of the system. But I wrote the chapter, obviously, on genetics, classical genetics, and sent it off to them, and everything seemed to be great. But then at some point it was decided that they'd run this by another editor who was going to do fact checking and all sorts of things, which seemed like a really good idea to me. But I got it back, and every single place where I had used the words unchanging alleles in reference to Gregor Mendel, it had been changed to discrete alleles. Maybe you have to be a geneticist to care, but these are totally different meanings, number one. Number two, the whole point of Mendel's work was that these were unchanging. That's the point. And I mean, I probably spent just going back and double checking and triple checking what I'd done over that, even though I'd checked it and double checked it beforehand. The word that Mendel used, the German word, means unchanging. Okay? And so and his argument does not make sense unless it means unchanging. I went and scraped up some friends who are native German speakers, ran it by them to make, I just put all of this time and effort into it. And the reason I did it was because I thought the editor knew something, but they didn't. They didn't know anything. All they knew was this looks anti-Darwinian, and that's not the term that's used in other textbooks.
Wow.
So there was just huge amounts of, it was like swimming through molasses, all the time. It just felt like it would never end, and it was just, and then of course, I used other authors and things in there, and then you go in and you try to edit their stuff, and then other editors would get hold of it and do other things to mess it up. And by the time you've gone back and forth a few times, everything's just sort of, like this. And but here is what I am excited about with it. Number one, we own it, so where there are errors, we can fix them. Number one. Number two, I am certain that it is a better approach than is used in every other textbook that I've looked at. And I know that that's a pretty arrogant thing to say, but I'm pretty sure it is. There are times when I feel like maybe I should have been more aggressive in my, let's say, apologetics and things, but I really tried not to do that. I tried to keep it factual and presenting to kids, this is what's going on. You can choose, but here are the here's the information that will allow you to make an informed choice. And then obviously using things like pointing out that the people involved were in fact Christians, for example. I mean, why was it an Austrian, well, basically Austrian priest or monk was the guy who figured this out? It's funny, all of those sort of Enlightenment atheists and things weren't figuring it out. What was going on with Mendel?
Yeah. You could say that about all the founding fathers of the sciences, sure.
Pretty much, I mean, it's remarkable, isn't it, how many of them were clearly, openly, unapologetically Christian. I'm trying to think of exceptions. There were not very many. The exceptions sort of start coming on later on, after the really basic heavy lifting's been done.
Right. Yeah, they started to stand on the backs of those giants. Sir Isaac Newton he believed in Arianism, so he was very religious. He was Christian oriented, but denied the deity of Christ. But he loved the Bible, and he was a creationist. Also. Kind of similar to a Unitarian or a Jehovah's Witness.
Yeah, and it's amazing to me that he actually wrote apparently more religious stuff than he did the physics stuff, because he was so prolific and profound with the physics.
Yeah.
I guess the way that I look at it is, someone like Newton, I don't really understand what he was struggling with theologically. There must have been something going on there that I don't get.
Yeah.
But aren't we all?
Yeah.
Aren't we all struggling with things? I'm perfectly prepared to get to heaven and have Jesus say to me, yeah, you were really right about this and this, but wow, did you miss you missed the point? What were you thinking? With some other stuff. And so
I think Newton was a maverick in many ways, and he didn't like being fit into the mold of maybe of cookie cutter Christianity, if you want to call it that, And I think a lot of people were probably that way in his realm of just brilliance. He was eccentric, probably.
Yeah.
So I like to give him a lot of liberty and.
I'd be glad to give him as much liberty as I think I deserve and need. But
it said this is Creation Week for the Feast of Trumpets, so we're living the Creation Week right now. Have you heard about that? But the Creation Week is during the time of the Feast of Trumpets.
The creation started about the time of the Feast of Trumpets. Okay, I hadn't heard that before.
That's what some of the Jewish people they will how do you say it? They will posit that, right? So if you read Leviticus chapter 23, it says on the 7th day of the month, on the first day of the month, it'll be a day of shofar blowing for you, right? It'll be a Sabbath of remembrance, in other words, right? So before it's just called Yom Teruah, right? But then after, I think, the second exile, right, when the second temple was destroyed and some of the Jews were scattered, if I recall correctly, that's when this Yom Teruah or Feast of Trumpets festival then turned into Rosh Hashanah, right? What is called the Jewish New Year's. But biblically speaking, right, you know, the new year, right, according to the Bible, right, it can be found, I think, in Exodus 12, I think, where God says, this is the first month, right? And that's the Hebrew calendar. And that would be, I think, in around the month of March or something, right? So that's the Jewish calendar system.
Yeah, I'm trying to remember what the history is for us of considering January to be the first month.
It's that probably came from a Roman calendar system, right? You know, January is named after a god by the name of Janus, right? A two-faced god. One is looking backward in the past, one is looking forward in the future, right? I mean, before, right, when we were coming together in the first century, right, it was first you had the Jewish believers, right? Then afterwards, then you had the non-Jewish believers joining in, right? Acts chapter 10 is probably the first one. You had Cornelius.
Yeah.
Then afterwards, there was an influx of non-Jewish people coming over, right? And then Paul actually addressed it in one of his letters in Romans, right? Romans chapter 11, right? Just because, you know, God removed the natural branches, right? Don't you non-Jewish people or Gentiles get arrogant. Otherwise, you know, I'll do the same thing to you as I did to them, right? And so what happened, right? That then it actually, you know, then the non-Jews kept coming in, and then eventually what ended up happening was that the Jewish context was getting removed, right? And instead of, for example, following the Jewish calendar that God actually specified for them, right, we adopted a different calendar.
I'm assuming the Julian calendar.
Yeah, it's the Julian calendar.
Which is the one that I understand the Eastern Orthodox churches stick with. And then the Gregorian calendar came in. Do you know how the Jews? I honestly don't know, so I'm kind of curious. How did they deal with the shifting of the months of the year using their lunar calendar? Did they have a mechanism for that?
Yeah, for a shifting season, I think once every 3 or 3.5 years, they actually add in an extra month. Because, yeah, they didn't do that, right? For example, they have, you know, the Feast of Shavuot, or which, you know, we would call, some of us would call Pentecost, right? And that's supposed to be the wheat harvest, right? Yeah. So if they didn't add that month every, you know, 3 or so years, right? What would happen is that instead of having the wheat harvest on like the 3rd month of the Hebrew calendar, you may get it like, let's just say on the 2nd month, right? Which doesn't add up, right? Because if you look at the, you know, Bible proper, right, you know, it does mention that, you know, on this specified date, for example, right? My memory is a little bit vague there, but you will have some sort of harvest, right? An agricultural harvest. So the Jewish people, they find out, they're saying, okay, you know, we need to make a accommodation for this, you know, irregularity that sometimes, you know, the seasons can drift if we only use a 12-month calendar. So every 3rd year or so, right, we will add an extra month.
I'm assuming that they were doing this based on empirical observation.
Yes.
Yeah.
Yes.
You know, I remember, for example, when you're in Jerusalem itself and you're seeing different sects of Jews observing the Sabbath.
Right.
The Sabbath, at least in one area that I remember being in on a Saturday night, I mean, it was something like 10 o'clock at night. It was pitch black before they blew the trumpet to signal the end of the Sabbath, and then all the shops opened up. But it had to do with being able, the rabbi in charge being able to see 2 stars or something.
I think it's 3 stars in the sky. Yeah.
Yeah, something like that. And they weren't going to, you know, you saw everybody just sort of standing around.
Yeah.
Kind and then blast with the trumpet, everything was open within a minute.
That's very funny.
It was that was an interesting thing. But what interested me was that they did tie it not to a time, but to an empirical observation.
Right.
And that was what they settled on.
Yeah, that's what they did. It was basically by empirical observation, right? Initially, right? Because the way that they would tell that there's a new month is they would look for the first sliver of the new moon, right? Yeah. And then afterwards, then they would, right? Garth was showing a demonstration. They would actually blow a shofar. Not only that, but they would also have a torch, right? And they would be high up in the mountain, right? To make sure that they can see the sky. Yeah. And then afterwards, then they would, they would use this torch and then, signal to the other people, hey, it's the start of a new month, right? And then they would, blow the shofar, right? And continue to, send signals to other communities. That's how they did it originally. But then, of course, then there was anti-Semitism going on, right? And by the I think around the 4th or 5th century or something, right? They were really getting ousted out of their land, right? And yeah. you had someone, I think his name is Hillel II or something. That's when he says, okay, in the case that we can't have this system, if I recall correctly, we're going to devise this calendar system, right? And I'm just basically going to make this calendar system based on things that we have experienced in the past, and therefore I think that's where you have the birth of the Jewish calendar that is used around the world today.
Okay. Yeah. Well,
excuse me, gentlemen and ladies, I think I'm going to shut down for the evening, but Philip, thank you very much for a great meeting. Garth, great seeing you again. And Dr. Standish, is wonderful chatting with you tonight. And everyone else who I didn't get to talk with, God bless you. Real privilege. We'll look forward to seeing you a month from now, huh?
Yes, it'll be great and exciting, Bill. By the way, did you get my private chat message giving you his email address? If not, I'll just send you an email too.
I didn't notice it yet. No, I'll check it. Yeah. Oh, okay. I think I can check it right now. Yeah.
All right.
Yeah, I'm getting ready to turn into a pumpkin too, so I'm gonna.
Oh, good. Yeah, got it. Thank you.
Yeah, no problem.
All right.
God bless you guys.
You all.
All right, God bless.
Seeing Bill next month, and we'll see all of you next month. God bless.
Thank you.
All right, God bless.
All right. Bye-bye.
Bye.
God bless. I don't know whether we need to shut down for everybody. I know that it isn't quite the witching hour, is it? But
I'll leave you with Philip. I got to go, and yeah, you could stay with Philip. Philip can shut the meeting down whenever you want.
Okay. Well, thanks so much for inviting me. God bless. God bless you, Garth.
I think, Garth, you have to make me the host. Otherwise, if you leave, then the meeting will end.
There you go. It might all be over. That's fine. Let's call it a night.
Okay.
And whatever. Stay in touch, and hopefully one of these days we'll be able to actually get together again.
Yeah.
Yes. All right. God bless you.
Okay. God bless.
Bye-bye.
Bye-bye.